Okay, so here's kind of what we're doing today. It's a little more specific than I probably even needed to get, but we're going to be taking a look at roots. How do you solve radical equations? Square roots, cubed roots, fourth roots, that kind of stuff. How do you solve absolute value equations? And then two of these are kind of the same. I put in here fractional exponents, but if you remember back to Algebra 2 again, think about like square roots, remember, are just the 1/2 power. Cubed roots are really just the 1/3 power. So roots and fractional exponents are really the same thing, just in two different formats. Okay? It's really the same concept. I'm going to preface today by, there's some hard stuff today. Okay, I'm going to give you a heads up that in advance, we'll kind of start off with a little bit easier example stuff you've seen in Algebra 2, but then we're going to end up pushing it a little bit further today. So bear with me, and we'll get you there. We'll make you understand it. But just a heads up that there's some hard stuff going on today. So here's where we've been. Here's what we've done over the last so far in this chapter: basic equations and eliminating fractions, rational equations. Okay, that's where we introduce the idea of the extraneous solutions again. Still clearing fractions, but algebraically. And then the last couple of days, we've spent all these different methods of solving quadratics. So today, here's where you should start taking notes, right here. Okay, solving equations that have radicals in them. And once again, we are going to have to check for extraneous solutions because we have restricted domains. Meaning there's values of x that you're not allowed to have. For example, we can't take the square root of a negative. You get imaginary numbers. You can't take the fourth root of a negative. So you got to keep in mind, you're going to have to go back and double check some extraneous solutions on this one. And we'll talk about that when we get into the examples. Here's the general rule. Here's what we're going to take a look at. This is generally how we're going to solve these types of problems. You're going to isolate and then eliminate the radical. Get the radical by itself, and then let's get rid of it to try to make that problem simpler. That's the main idea for this. Radical by itself, and then get rid of the radical and solve the resulting equation. Okay. All right, so here's example number 1. Here's something that you saw, something similar to what you would have seen last year. This will get at least the main idea going on here. Okay, based on what we just said on the other slide, what do you think the first step is? What would you do first to solve this? What is it?
Add 5.
Yeah, we got to get the radical by itself. Therefore, anything outside of the radical, we have to eliminate that. We got to move it to the other side. So we're going to add 5 first. So we have the cubed root of 3x plus 1 equal to 5. Now what? What do we do next? Yeah, cube both sides. Because now I want to get the radical out of there to make this problem easier. So we're going to cube both sides. Left-hand side, when you cube it, that radical goes away, leaves you with 3x plus 1. Right-hand side, when I cube the 5, we get 125. And now we solve. Now from here we go through and we just solve the equation. Subtract the 1 over. We get 124. Divide both sides by 3, and it doesn't go in nicely. It's like 41 point something? 41.3, I think. 3 repeating. Am I right on that? I think so. Yeah. X equals 41.3 repeating on that one. Okay. Or if you wanted to leave it as 1/24, that's perfectly fine too. Okay, you could leave it that way. Quick question on this one. We talked about the idea of extraneous solutions, and sometimes you have restricted domains. Let's talk about cubed roots for a second. We said square roots, you can't have negatives underneath the radical. You can't take the square root of a negative. You get imaginary answers. Can't take the fourth root of a negative. What about odd roots? Can I take the cubed roots of negatives? For example, what's the cubed root of negative 8? Can I do that? What's the answer? Negative 2. Remember when I asked you what the root is, if I say what's the cubed root of negative 8, what I'm really asking you is, what do I cube to get negative 8? That's what a cubed root is. That's what a square root is. That's what a fourth root is. Okay, that's what you're dealing with. And so you can take negative 2 times negative 2 times negative 2, you get negative 8. Okay, so in this scenario, I don't really have to worry about plugging this back in and checking it, because I can take the cubed root of anything. Positive, negative, 0, doesn't matter. So this one's gonna work. I don't have to worry about that. It's the even roots that you got to worry about. Okay? Remember doing this last year? All right, so there's the refresher. Now let's go a little bit more difficult. Now we went from 1 radical to 2. Still the same idea though, same concept. Isolate a radical, and then let's get rid of it. It really doesn't matter which radical you get by itself. You just need to get one of them by itself, and then go from there. I'm going to take this square root of x minus 5, and I'm going to add that term over to the other side. So ultimately we get the square root of x plus 5 equal to the square root of x minus 5. And it turns out that not only did I isolate one radical by doing that, I actually isolated both of them. They're separate on either side. There's nothing else there. Now I can get rid of those square roots. We can go through and square both sides. Left-hand side, I get x plus 5. Right-hand side, I get x minus 5. The radicals go away. And once again, we go through and we solve what's left. If you notice on this one, if I subtract the x over, those x's are going to cancel out. You end up with 5 equals negative 5, which obviously is not a true statement. So what's the answer to this problem? There's no solution. Yeah, there is no value of x that's going to work on this one. This one is no solution. This one is no solution. So we started with 1 radical, went to 2 radicals but had 0 on the other side, so it wasn't too bad. Now we're going to go one extra step, one more step here. And that is 2 radicals plus something else on the other side. And this type of problem will be about as hard as this will get. This will be the hardest type of problem you'll see with radicals. Still going to follow the same idea. Okay? Isolate a radical. Now, on this one, I'm going to be a little bit smarter about this one. I'm going to isolate the more complicated radical. Okay? So I'm going to actually take the square root of x and subtract that over. I'm going to get the more complicated radical by itself. So if we subtract that over, we've got the square root of x minus 20 equal to 10 minus the square root of x. We do have a radical by itself, so I can get rid of it. Now I can eliminate that one. I'm going to square both sides since we're dealing with square roots. Left-hand side, radical goes away. You got x minus 20, so it's starting to get a little bit nicer. Be careful on the right-hand side. Number 1 mistake in all of algebra again. You cannot just square each thing, okay, each term. You can't do that. I can't just square the 10, square the square root, and everything's gone and we're good. That doesn't work out. What does it mean when you square something? What do you do when you square something? multiply it by itself, which means 10 minus the square root of x, we need to multiply by another 10 minus the square root of x. And we're going to have to multiply this out. We're going to have to FOIL this out. Okay? So, let's start the process. I'm going to take the 10 and distribute. 10 times 10 gives me 100. And then we're going to multiply that by that negative square root of x. Reminder, when you multiply square roots, anything that's not under a radical stays on the outside. Anything that is under a radical stays on the inside, stays underneath. Okay? So when I multiply 10 times negative square root of x, I just get negative 10 square root of x. Okay? 10 isn't under a radical to begin with, so it stays on the outside. X is, so that stays on the inside. Then we move over. Now I'm going to distribute the negative square root of x. When I multiply that by 10, we get another one of these, another negative 10 square root of x. And last part, negative square root of x times negative square root of x. Negative times a negative is a positive. What do we get? What's the square root of x times the square root of x? It's x. Okay? You're squaring it. Okay? So the other way of thinking about it is this is the square root of x squared if you multiplied it, which takes you right back to x. Okay? So good news is this. I'm going to clean this up a little bit here first, then we'll talk about it. So let's go through and let's combine like terms and clean this up a little bit. Because these are both square root of x's, the only time you can add or subtract square roots is if they're exactly the same. Square root of x's can only go with other square root of x's. Square root of 5s can only go with square root of 5s. Okay? That's the only time you can add or subtract those. So I can put those two together to get negative 20 square root of x. You got negative 10, you got another negative 10 for a total of negative 20. Now let me get into the good news. Good news is we started with 2 radicals, we're down to 1. Bad news is I still need to get rid of that. So we start the process over again. Okay? Meaning we're back to isolate a radical. Let's get the radical by itself. The good news about this, though, is it's now going to get much simpler. Okay? We've done the hard work. So now let's get that radical by itself again. Subtract the 100 over, subtract the x over. When I subtract the x, these x's actually will cancel each other out. Those go away. Subtract the 100, we get a negative 120 equal to negative 20 square root of x. And now at this point, you could square both sides right now if you wanted to. That would be perfectly fine. But I'm going to go one more step. I'm going to divide both sides by negative 20 only because 120 is divisible by that. If this wasn't divisible, I wouldn't go through and want to divide it and create a fraction. I would leave it and square it right now. Okay? But because it's divisible by that, we're going to divide. Square root of x equals 6. And we're almost there. Now I can get rid of the radical. Square both sides. And we end up with x equaling 36. Last question. Do I have to check that answer? I do. Because I'm dealing with square roots. And I cannot get a negative number under the square root. I got to make sure this one works because we're dealing with an even root. So if we just plug it back in, you can do it in your head. If you just plug it back in, square root of 36, that's 6. Plug it in here, 36 minus 20, that's 16. Square root of that is 4. 6 plus 4 equal 10? Yep, we're good. It works. Okay? So it had the possibility to be extraneous. It wasn't in this case. How we doing on radicals? Like I said, we ended up with 1, 2, and then now this one where we had to kind of a longer process. Any questions before we move on? Okay, then let's keep going. That's the idea of radicals. Then we get into the second concept that we're going to take a look at, which is absolute value. We're going to kind of put 2 parts here. Solving equations with absolute value. And we'll talk in just a second here, recall about what you know about absolute value. So first question, what is absolute value? What do you know about it? What do we know? If you were going to tell somebody what absolute value actually is, how would you describe it to somebody? Just the concept of an absolute value. What do we think? Yeah?
Just the distance and distance.
That's exactly what it is. It's distance. It's the distance from 0 on a number line. So for example, if I asked you what's the absolute value of 15, it's 15, because it's 15 spots from 0. If I asked you what's the absolute value of negative 15, also 15, because it's still 15 spots from 0. So absolute value, you always have two answers, because there's two numbers that are the same distance away from 0. Always. Okay? And your answers always need to be positive. Because again, we're talking about distance. You may have seen this up here. You may have looked at, if you notice my avoid negativity, do you get it? It's an absolute value. That absolute value is always positive. Haha, stupid math joke. Yeah, I know. I get it. It's corny. Avoid negativity. Absolute value is always positive. That's what that is about. So the idea here, though, is we have two answers always. That's the main thing. Okay? So, once again, let's introduce kind of what you did last year in Algebra 2. Here's to get the concept, and then we'll move it up to make it a little bit more difficult on the second example. So here's the concept. I'm taking the absolute value of something and I want an answer to be 7. What numbers, when you take the absolute value, do you get 7 as an answer? Absolute value of what gives you 7? 7 or negative 7. Absolute value of 7 is 7. Absolute value of negative 7 is 7. The reason I asked that it does not matter what's inside. That means whatever's inside has to equal 7 or negative 7. There's your two equations. 3x plus 2 had better either equal 7 or negative 7. If it equals either one of those, when you then take the absolute value, you'll get 7 as an answer. And there's where your two answers are going to come from. Now just solve your equations separately. Subtract the 2 over. 3x equals 5. Divide by 3, we get 5/3. There's one answer. If I plugged that in, I would get 7. Other one, subtract it. We get negative 9. Divide by 3, I find out that x equals negative 3. Now, quick question. We said absolute value always has to be positive. Is it okay that x equals negative 3? Yes. It cannot equal negative 3, but if I plug negative 3 in, I'm going to actually get negative 7 here. And when I take the absolute value, it will equal 7. Okay? So the absolute value cannot equal a negative. X could. It's possible. Remember doing that last year again? That was going back to last year. Two answers. Here's now where we're going to raise it up, something we didn't do last year. Here's kind of the pre-calculus version of this. Okay, keeping the same concept. Messier because now it doesn't equal a number, it equals an algebraic expression. But conceptually still the same thing. Just like we said here, whatever it's equal, it's got to either be the positive or negative of that. Same thing here. That means x minus 10 has to either equal x squared minus 10x or x minus 10 has to equal the opposite of that. the opposite of x squared minus 10x. There's your two equations with the same concept. There's just algebra in this one. And now we solve. So, in this first one, notice we've only got an x squared. I'm going to take this everything from the left and move it over. So we've got x squared. If I subtract that, I get negative 11x. Add the 10 over, I get positive 10, equal to 0. And what do you know? We're right back to quadratic equations again, like we've been working on the last 2 days. This one, though, is pretty straightforward. This one's factorable. We end up with x minus 10 and x minus 1, which means x equals 10 is one possible solution. X equals 1 is another possible solution. And then we still have to go to the other one and solve the second equation. Get out of your way. Make sure the one mistake that I can see people making if you're not careful is remember it's the opposite of the whole expression, not just the first term. It's not just a negative x squared. You got to take the opposite of everything on the right-hand side. So, x minus 10 equals negative x squared plus 10x. And once again, we've got a quadratic. Get it equal to 0, factor or quadratic formula, and solve. Let's see, this time I'm going to add the stuff from the right over to the left. So we've got a positive x squared. If I subtract that over, we end up with minus 9x, and then we have minus 10. And once again, this one's factorable. X minus 10, x plus 1, which means x equals 10 is one answer, which is really just a repeat of an answer we already had. And then the other one, we get x equals negative 1. Quick question. And this is about as hard as the absolute value ones will get. Quick question, do I need to check these answers? Yeah, because absolute value is restricted again. There's things that x cannot equal. For example, if I were to plug 10 back in, we just check to see if you get the same answer on the right and the left and if it works out. If I plug 10 back in, well, 10 minus 10 is nothing. Absolute value of 0 is 0. If I plug it in over on the right-hand side, 10 squared is 100. 10 times 10 is 100. You get 0. So 10, that one checks out. If you plug 1 back in, I get negative 9 here. Absolute value of that is 9. Then we got to check over here. I plug 1 in on this one. 1 squared is 1. Minus 10. I do get negative 9, but what's the issue? Can an absolute value equal negative 9? No. This one is extraneous right here. X equals 1 is an extraneous solution. Because the answer you get on the right-hand side is negative. You can't have an absolute value equal something negative. It's not possible. And just to save you a little bit of time, if you plug negative 1 back in, it does work. So you end up with two answers, 10 and negative 1. One of the answers happened to be an extraneous solution. How are we doing on this stuff, okay? Feeling all right so far? All right, let's go into one final thing. This is just a different version of what we've already done with radicals. Okay? So you've got a quadratic raised to the 4/3 power. And I'm going to show you two ways to do this. That way, whichever way you like, you can kind of work off of that. So quick reminder, when you're dealing with fractional exponents, remember we said the square root is the 1/2 power, cubed root is the 1/3 power, fourth root is the 1/4 power. What does the top number represent in the fraction? Remember? More importantly, what does the bottom number represent? Power over root. The bottom number is the root that you're taking. So when I say the 1/2 power, that bottom number being 2, that's the square root, raised to the first power. The 1/3 power is the cubed root, raised to the first power. The 1/4 root, raised to the first power. Okay? So this is really the cubed root of this quadratic, all raised to the 4th power. Let me show you option number 1. Okay? Kind of put that over here. Here's method number 1 of solving. And like I said, I'll give you 2 options. I honestly don't care which way you do it. Whichever way makes more sense, whichever way you think is easier, go with it. I'm going to rewrite this as a radical and kind of think about it what we've already done. So we said the bottom number is the root. So I'm going to write this as the cubed root of all of this stuff, x squared minus x minus 22. We said the top number is the power. All of that raised to the 4th power. So that's the exact same thing. That's the exact same equation, just in radical form versus exponent form. Now, if we're trying to now start to undo things, what would you undo first? What would you get rid of? What do you think? Where do we start? Triton, what do you think? Help me out.
4.
Yeah. Start on the outside, work your way in. How do I get rid of the 4th power? Take the 4th root. Okay? We're going to take the 4th root of both sides. Let's start there. Take the 4th root. Take the 4th root. On the left-hand side, that'll cancel out your 4th power, leaving you with this stuff. On the right-hand side, what's the 4th root of 16? 2. Remember what I'm asking? What that really means is what raised to the 4th power gives you 16. Okay? And since I took an even root in an equation when I'm solving, what do I need? Plus or minus. Just like when we take the square root in both sides, anytime you take an even root, you have to have a positive or a negative. Okay? Plus or minus. Okay, what do we do next? Now what? What do you think? Let's keep working. Let's keep getting rid of things. What's the next thing that needs to go? The cubed root. How do I get rid of the cubed root? Cube it. Yep. Let's get rid of this let's cube both sides. Left-hand side. Cubed root goes away. X squared minus x minus 22. Right-hand side, you're going to get 2 answers. Plus or minus 8. And now I'm not necessarily going to stop here, but now what would you do to finish this up? You got a quadratic equation. Assume it equals the positive 8 first. Get it equal to 0. Solve. Then assume it equals a negative 8. Get it equal to 0. Solve. Whether it's quadratic formula, factor. I think at least one of them. I think both of them are factorable. I might be wrong on that. But the idea is now you basically have 2 equations. This quadratic equals 8. And then this quadratic equaling negative 8. Solve each of those separately. Get them both equal to 0 and solve. Okay, so I'm going to kind of that goes back to that. Make some sense? Can we handle it from there? Hopefully. Because again, that's what we've been working on these last couple of days. So I told you that's option 1. That's where if you don't like the whole fractional exponent idea, we can change it into radical form and work our way through. Here's option number 2. Let me put that over here. If you remember back to some of the exponent rules, okay, we're dealing with exponents. Remember back where if you have got the same base and you're multiplying, you add the exponents together. If you're dividing, you subtract the exponents. If you've got a power re-raised to another power, you multiply the exponents. Okay, all of those kind of things. That's what I'm going to do here. I'm going to take this equation, this x squared minus x minus 22, that's raised to the 4/3. And in order to get rid of that, let's say I want to, in one step, try to get rid of that 4/3. Here I did it in 2. I got rid of the 4th power, and then I got rid of the cubed root. We can do it in 1. I'm going to re-raise both sides to the reciprocal power. So instead, I'm going to re-raise this to the 3/4 power. I'll explain why in a second. Same, and if anything, if you do it to one side, you got to do the same thing to the other. So I'm going to re-raise this to the 3/4 power as well. Anybody tell me why? What happens when you've got a 4/3 power re-raised to the 3/4 power?
Because when you have to multiply x, when you like have a raise an exponent to an exponent, you multiply them together. 4 over 3,
Yep.
3 over 4 is 1.
When we power to a power, one exponent re-raised to another exponent, you multiply the exponents. And when you multiply something by its reciprocal, equals 1. Which means by doing what I just did, we just got rid of the exponents. So on the left-hand side, I now have x squared minus x minus 22. On the right-hand side, we can actually evaluate that. Remembering, top number is the power, bottom number is the root. What's the 4th root of 16? 2 raised to the 3rd power, 8. Bottom number is the root, top number is the power. But again, because it's an even root, you got to have the plus or minus. Plus or minus 8. Notice where we're at. Exact same place. Okay? So you can either get rid of the exponent in 2 steps, or you can re-raise something to the fraction or the reciprocal exponent and get rid of it in 1. Okay? It's a little quicker to do it this way if it makes sense. If this doesn't make sense, then don't do it that way. Okay? Even if it is quicker. I'd rather have you doing something that you understand versus doing something that's quick, but you really don't know what's going on. Okay? We doing okay? Like I said, there's a little bit of all this stuff. See what I mean, by the way, at the beginning where I said there's some hard stuff today. Okay? This is going back to some of the harder stuff that you learned in back in Algebra 2. All right. What I'm going to have you do then, I'm going to skip this last one. By the way, quick question. I'm not going to do it, but let me just ask you this. If I were going to solve this is going back, a little review here quick. We want to eliminate fractions. What would I multiply everything by? What's my common denominator? X times x plus 5. Yep, your 2 factors. One of them's x, the other one's x plus 5. Multiply through, and then back to rational equations again. So just a reminder, because I think there's a couple on the assignment as a review. All right, so here's the assignment that I'm actually having you do. It is a much shorter assignment than the ones you've been working on the last 2 days. You have 167 to 185 odd, so you've got like 10 questions. Okay. And we are now about halfway through the first chapter. We got about another week or 2, and then we'll test on the end of the chapter. Oh, yeah.
It's a good day.
Read all the answers check out. The other one was 4.27. That's negative 3.27.
Well, I just left it at, where we can get these at. Mr. B.
So,
What's up, bro?
normally